Hello there, YouTube friends. Welcome back to N9TAX Retro Lab. Today we have an interesting thing to take a look at. I have this Princeton Graphics CGA monitor that has a collapsed vertical. So vertical sweep is collapsed. We're going to have to crack it open and take a look inside. Now, I recently purchased a IBM 5150. As you can see, it's right down there waiting to be tested out. The problem is I don't have a monitor to test it out with. So until we get this Princeton Graphics monitor fixed, and here I'll give you a show of that here real quick. This is the monitor. Not 100% sure, but I think a lot of these were just clones of the IBM 5153. And if I remember correctly, those are pretty easy to work on. I did find a service manual online, so that's going to make things a little simpler. Anytime you can find a service manual, you should be looking for it, because boy are they a lot of help. Okay, so in the service manual, as you can see now, there is a couple of things to check for no vertical sweep. It wants you to check the B plus to see if there's 25 volts on the rectifier circuit. If it's low, you have a failure of the rectifier circuit. That'll be a simple one if it's just a voltage problem. Or it looks like we short a 22nd pin sync signal to the 17th pin on IC 301 through a capacitor. If we get some vertical, then we have a failure of IC 301. Isn't that something? It also says failure of DY when AC signal obtained on 9th pin of IC 302. So we'll have to see what exactly it is that means, but let's look at what it's doing right now. So right now, if I turn this monitor on, I'm not sure where the brightness is, but we may have to adjust that. You see we just get a nice collapsed line, and let's turn that down so we don't do damage to the monitor. So what we have is we have video, so we know we have high voltage, we know we have horizontal sweep, which is good because those circuits are much more complex than the vertical sweep circuits. We're just not scanning vertically. So all of the video information is just living on this one line. I'm going to turn that off because, again, it's not good to leave that on. It can burn in your monitor if that's on the screen for too much. I'm sure it would have to be on for more than just a few seconds. But let's crack this bad boy open and take a look inside and see if we can't figure out why it's doing what it's doing. Oh, so let's see what it takes to get this guy apart here. First, we're going to remove the AC power. Shouldn't take anything apart with a power cord plugged into it. That's pretty standard. I see a couple of Phillips screws up top, assuming those have to come out. Probably going to have to lay this on its face, so I'm going to run and see if I can't find my towel. Learned this one from Adrian. Apparently, always keep an old towel laying around. Of course, one that your wife doesn't mind you using for this sort of thing. Lay it down on the bench there, and then we can keep from scratching things up. Oh yeah, we've definitely got some more screws on the bottom here, so let's get these out. Incidentally, the two front screws are painted to match the color of the case, as are the two top. These back ones here are what looks to just be a stainless steel sort of color. So that's an interesting, and they're a little bit different because they're not pointy. So always remember where the screws come out of. Might be helpful if you have to put them back. Sorry if there's any background noise. I live underneath of a missile testing site. Oh, yep, that was it. 2 screws and she's off. Just be careful when pulling those off. We do have the neck board here, and that's probably the most, wow, look at that. So what distracted me really quickly here, and I'll bring you a little bit closer to take a look at that, is on this neck board here. I don't know if you can see that. There's some really cruddy looking cruddies on some of these. I'm not sure what that, you know what I think that is actually. I will bet that in the back of this thing. Can you see it before I can? Little black square in there? Yes. There is a piece of foam back there to protect the neck board, and it's okay. And it scared me for a moment. I thought maybe there was some corrosion there. So now, on these older monitors especially, some of the newer ones have built-in circuits to discharge the tube. These older ones, you have to be very careful. These tubes can hold a charge for quite some time. Now you can just use a screwdriver to do this, and incidentally, I'll give the age-old warning here. If you don't know what you're doing in electronics, the last place in the world you should be is inside of a CRT. So please don't get inside of a CRT without understanding what you're doing. There is a ground wire that runs and kind of wraps around the tube. It's called the DAG ground. If you clip your ground lead on that, and this is a voltage probe. In fact, I have another one of these with a meter on it. Let's use that one. This one here, you got to hook to a voltmeter to get it to work. I forgot I have this ICO one as well. This one will actually show a little voltage. I'll try and capture that if there's some charge in this, because we did just have it turned on, so we might see a little bit of discharge voltage come out. You can just use a screwdriver with a wire wrapped around it. Anything that will get underneath of the high voltage little anode cap here. Hopefully there's enough light for you to see this anode cap. So yeah, you want to get underneath of that with your probe, like so. And here we'll watch the meter to see if there's any discharge when we get back in there. I don't see anything. Hopefully we're hitting. Yeah, I can see the metal in there. Yeah, if there was any power actually in there, you would see the meter on that go up. But anyway, now that we've probed in there, we know that we don't have to worry about shocking ourselves with high voltage from the tube. So, whew, this is a fun looking monitor inside. Look at this big. Is that a transformer maybe inside of that can there? That's a really interesting sort of situation. Get the camera going on here. So typical stuff if you've never been inside of a monitor. This is likely a transformer for power. Not 100% sure. Over here we have the high voltage stuff. You have your flyback down here, or actually no, the flyback is down under here. This is like a high voltage splitter that will take, I believe, high voltage from here, and then it comes into this and feeds into the neck board for the I think is it the grid voltage? I'm not 100% sure, but yeah. And then of course you have your anode voltage that, you know, feeds down on your anode cap here. And yeah, that's it. That's so basically there's a circuit that feeds two circuits inside of this, which is the deflection yoke. This is just a big electromagnet, and it'll be fed voltage that will cause the stream of electrons heading towards the front of the tube to either swing this way or this way, and then there's another field that will be created that allow them to swing up and down. So the voltage that is supposed to be feeding this to allow this to swing up and down is the voltage that we're missing, and that is what we got to figure out today. And probably the most difficult thing here is going to be able to figure out how to work on this thing, because I don't know if you can tell, but you know, the board is underneath of all of this stuff. So hopefully there's, and if you look at these, sometimes there's wires wadded up like this with a little tie around them, and the reason for that is so that you can loosen things up and get the board slid out, you know, slid out like this in order to get to where you can work on things. So see if we can't try and figure out where the B plus voltage on the rectifier circuit is supposed to be, and then maybe get this guy fixed. Let me dig in the manual a little bit, and we'll see what we can see about where that's located. Possibly something that I can probe here without getting down into the guts of this thing. So let me take a quick look. me get the board, see if I get the board slid back and figure out how to work on this thing. I'll be back in just a moment. Just taking a look here on the bottom. I should probably always check these things for bad solder joints and whatnot. Get you into the overhead view here. So because these components are heavy, things like the flyback can end up with bad solder joints. Now, I don't know if that would affect vertical deflection. It's probably hard to see there. It's not in focus. There looks like there may be potentially some cracks in those solder joints. But it's always good to, any heavy connectors that are hitting the board, things that have wires hanging off of them, stuff like that, look for any sort of damage from stress and things like such. I'm not seeing anything that looks too bad here. No, it really looks okay. Trying to just decide what's the best way to take this thing apart. Sorry about that light. It looks like maybe I can unbolt this whole frame and pull the entire thing back from the tube, or even move the tube forward. But yeah, that's typically the biggest problem with working on stuff like this, is getting access to the components that you need to get at. I haven't even found IC301 yet. I wonder if there's a map in here. It's like, you know, of the board that shows the layout. I know there's schematics. Those are good, but you know, like a board layout is very helpful. There we go. Yeah, that is a bigger IC. It's all the way up front underneath the, let's see if I can give you a view of that. Yeah, it's down there underneath of the tube. You can see the pins of it there at the edge. Yeah, okay, so that's IC301 over there. That's going to be the vertical driver chip. Let's see if we can't get inside of this thing. I'm going to have to let some of these wires loose. And you know, like I said, they bundle these wires up, so I should be able to release these little ties and get some length on some wire. I think they do that on purpose so that you can service these things, right? Of course, they are not easy, but yeah, I can get the wires free. So I think it's gonna be a game of get some wires free, and a couple of screws in the front here that I can get off, and I believe I'm going to be able to slide this whole frame back. Of course, once I do this, yeah, the plastic should still support the CRT. These things are very precarious to work on, just because you cannot get at the boards in a lot of cases to even look at things. And I think a 3-foot long screwdriver would be the way, because everywhere they've put a screw, you can't get the screwdriver in there. Like here, I cannot get the screwdriver. Look at this. This is absolutely ridiculous. So you want to take that screw off down there, right? Nope, you can't. Why? Because the screwdriver won't go past the stupid screen. I mean, really? Did they not have normal length screwdrivers when they built this monitor? Criminy sake. It's just fascinating to me how these things are put together in such a way that they could like never be taken apart again. Am I complaining? Sorry. Didn't mean to complain. It was the 80s. They had Quaalude back then. There's the 80s. Oh yeah, look at that. Look how we got access to things now. So, looking down there, a lot of strange bodge wires here. A lot of strange bodging going on. So, front wires allowed me to slide it back a little bit. I mean, ideally, you can loosen these things up enough to give yourself room to be able to turn this thing on while you test it. I mean, right? All right, so what can we test right now? We have, I believe, access to IC301. Some capacitors up here. Incidentally, I kind of looked at all the caps on this board. I don't see anything swollen, so early 80s caps are really pretty reliable. They don't always go for those first. I'd be more willing to believe that this chip is kapooped. So, IC301. I do not see an IC301 silkscreen. Wait. There it is. Yep, that's IC301. So, let's get back to here. Now, this is IC301 over here. It's an AN5410. And what does it say? Failure of IC301. Failure of DY. DY? When AC signal obtained on 9th pin of IC302. DY is the deflection yoke. Duh. Okay. So it's saying, yeah, all right. But we can check the deflection yoke. Actually, that's pretty easy to check, really. On this one, because it looks like there's, let me get you involved here. Looks like right on top of the yoke here, we have our pins for the input. There's a blue and yellow on this side and a red and green on the other side. And I believe red and green is horizontal and blue and yellow is vertical, but don't hold me to that. What I do know is that there should be resistance across that coil. If the coil is blown, there will be no resistance. So I suppose that's a good thing to check first. I should probably unplug it. On the schematic here, does it say what color the wires are? No, because that would be helpful. DY1, DY2, DY3, and DY4. Okay, it's 1, 2, 3, 4 labeled from the back of the board. So 1 and 2 are horizontal, and that is blue and red. Okay, so it's the back 2, and then the front 2, green and yellow, are vertical. Simple enough. Let's check that. Put the old meter on. So this is across the horizontal coil. 100. Probably not getting a good connection here, but 3.8 ohms. Not 100% sure that's what it's supposed to be. 12 ohms across the vertical. What I'm trying to do is the plug on the board down here. It's underneath of the neck board, And it's got some glue on it to keep it from moving, which is nice of them. But it is making it very difficult to remove. And I'll show you what I'm doing there. I'm trying to pry that big long plug up. Let me get this guy out of there. I just don't want to be measuring in circuit. So I do believe the resistance on those ought to be a little bit higher. Wowee. This is certainly helpful, Princeton Graphics. Thank you for gluing this down so well. Okay, I have a jumper wire. So what's it want? Pin 17 to 22. So this is a 24 pin, right? 4, 8, 12 looks like. And pin 22 is going to be there. Take this bar off the side here. I'll pull this bar off here. This will give me access to that chip. Oh, yeah, look at that. It's 12, 13, 14, 15, 13, 14, 15, 16, 17 is there. 22 is there. Okay. So what I did here, to get all the high voltage wiring out of, is I jumpered that chip. I don't know if you can see it there. There's an angle we can maybe work with. I put some jumpers on that chip. Pins 17 to 22. On the suggestion of the manual that if I jump that and I get deflection, then I have a bad chip. Seems like an easy thing to test. So now is where it gets dangerous, because I have to plug this back in with the cover off. I have to make sure I have nothing touching anything, and it's also going to be difficult to look at since the screen is on the other side, but I'm hoping we can use our nice little camera here to see. Oh man. Nope. Still have a collapsed line. Okay. It's probably good because that's a funky old looking chip and I don't have any, so. Let's see. I don't believe we have a bad deflection yoke, which means that the problem has to be the B+. Now, I got to go and look and see if I can find this B+ on the board here. So I'm going to go ahead and turn the cameras off for a minute and do a little think on that one, and then I'll catch up with you as soon as I figure out exactly where that B+ is. So stay tuned. I'll be right back. Okay, so there is a fuse that looks like it might be for the B+. I'm going to go ahead and check that. Let's see how much voltage is on it. The fuse has 120 volts on it. Alrighty there, everybody. We're back, and through the miracle of modern editing, we now have the chips that we need to fix this monitor. So now what I got to figure out how to do here is get this board out enough so that I can remove and replace that chip. So probably do a little time lapse here and let you watch me figure that out. Just real quick, if you're ever going to work on these tubes, make sure you always discharge that high voltage. Find our DAG ground. Okay, we're back. So I was able to get this unit separated from the monitor here, as you can see. Let me get you down there. And now it's going to make it a lot easier for us to replace this vertical deflection chip here. Hopefully, the manual says it's bad if it doesn't do the things that it didn't do. Hopefully replacing this thing is just going to bring this guy back to life. Probably not, but hopefully. Yeah, it was kind of a little bit of pain to work on these where there's not enough wire to get them slid all the way away from the tube while they're still connected. So, you know, we took the control bracket off the front, and I did have to cut one ground wire just because it wasn't easy to detach from the board here. So that's easy enough to put back later. So let's take a look here. See if we can't get this chip replaced. And with any luck, bring this guy back to life. Let's see, as our iron is just now heated up. I like these Hakko desoldering guns here. This is... The manual says it's bad if it doesn't do the things that it didn't do. Hopefully replacing this thing is just going to bring this guy back to life. Probably not, but hopefully. Yeah, it was kind of a little bit of pain to work on these where there's not enough wire to get them slid all the way away from the tube while they're still connected. So, you know, we took the control bracket off the front, and I did have to cut one ground wire just because it wasn't easy to detach from the board here. So that's easy enough to put back later. So let's take a look here. See if we can't get this chip replaced. And with any luck, bring this guy back to life. See, as our iron is just now heated up. I like these Hakko desoldering guns here. This is probably some of the best money I've ever spent. He's really good at getting So, we got most of the solder cleaned out there. Of course, they've bent a number of the pins down in order to make my life more difficult. So, Let's see if we can't get those straightened out. And it's all about the manufacturing. You know, when they put this thing together, bend those pins down in the corners. It helps hold the chip in for them while they solder it. So it does not make our lives easy when the chip burns out and we have to replace it. I feel like it's starting to let go. One of the nice things about working on older CRT monitors is they're rarely double-sided, so you know there's not a ton of danger of ripping up any of the top traces or the bottom traces. There are no top traces. And the trusty chip lifter tool here. And, oh yeah. Now this light is making this no good, huh? There you go, focus in on that. So yeah, she's nice and loose. And she's ready to come right out. Again, like I said, you're pulling the traces on the bottom if there is a little bit of solder sticking it towards the board, so there's really no danger of damaging traces when it's only a single-sided board, which is very nice. And there it is. That's nice. The AN5410, a venerable junk bad chip, maybe. I don't know. Hopefully it was bad. This is just the cure. Did buy a couple of them, so I suppose we have a couple of shots at making this work. Oh, hopefully. Hopefully I only need one. They look new. Oh yeah. Yeah, that's never been used. Yeah, those pins are clean. It's one of our nice leg straighteners there to make her go in real nice and clean. Get the leg straightener, look at that, she just dropped right in there. Clean as a whistle. It'll stay in there when we get it soldered. We'll have it made. Have a little leaded solder for this one. Use the unleaded process most of the time, but newer stuff, these old things, I like to put the leaded solder in there that way. Sure, what's on this board now is leaded. Keep it original, as it were. I tack a couple of corners. That way it'll hold in there nice for me. I don't have to hold the other side, the other two corners. And we can just solder away. Yeah, look at that. All right. And no pins were bent down in the soldering of this chip. Well, so now all we got to do is put it all back together and see if it works. Well, this wire here was soldered to the tube, or not to the tube, sorry, to the DAG wire. So I want to make sure that I get that soldered back on. Also don't want to put heat up against the glass, so I stuck this little screwdriver in there just to hold that wire away from the back of the tube there. Alright, so we got our ground wires reconnected. We can plug back in our degaussing coil. I did put a couple of screws back in it just to give it a little rigidity. I don't know if well, you know what, just for safety's sake, there is AC on this control panel here, so I'll go ahead and mount that back. I hate putting it more back together than I have to in case it doesn't work. Take it all back apart again, but we do want to be safe. We want to be safe, so. Well, we'll all watch it together. Let me get a power cord here and see, everything looks to be reconnected. Ah, no, we didn't fix the motor. Oh, that sucks. The book was wrong. It is not the chip. You know, as difficult as the schematic is to read, it's going to be very difficult to figure out what's going on here. Well, let me get it back in a position to do some more triage, I suppose. The chip is like down underneath of the CRT. That makes it very difficult to get in and probe things. Gosh darn it. I was really hoping that was going to be it. Well, I'm going to study the schematic for a little bit and see if I can't come up with a potential thing to look at next. So stay tuned. I will be right back. Hello everyone, I'm back, and I have news about this silly monitor. I'll show you the horrible service manual again here, and I don't know how well you'll be able to see this, but let me see if I can zoom in on what's happening here. This is the vertical hold and vertical height circuit. After looking at, well, you know what? Hang on one moment. Okay. After looking at the data sheet, this all started to make sense. And part of the problem is the scan of this manual is so bad that I was having a difficult time understanding what was going on. So now that I take a look at this, I see that we have 12 volt VCC. This is the AN5410. This is the chip that I replaced, that I surmised was bad because the manual said if the monitor is doing what it's doing, the chip is bad. Now, I'm not going to blame the manual 100% because after discovering what I discovered, I feel like it's not 100% the manual's fault for telling me that, because the manual didn't consider the fact that we would be trying to use this monitor 43 years later. Yeah. So here's power, 12 volts, VCC. And it's coming in here through these two adjustments. And what these adjustments are is the vertical hold and the vertical height. Pretty sure this is this one's height. This one over here is hold. So what you're doing is you're adjusting the amount of voltage you're feeding to pin 19 and pin 15. So let me take you back to the manual. And here it is. This is 13, 14, 15 comes over here, vertical height. 19 comes over here, vertical hold. This is a good lesson because I got in a hurry. Oh, I know how to fix things, you know what I mean? I'm going to troubleshoot with here's what's, supposed to be wrong methodology of using their troubleshooting tables inside of the manual, but the reality is what I should have done was really think about how this chip worked, and I would have quickly realized why it's not working. I haven't fixed it yet because I want to show you that, but if you look right here, there's this little arrow that's kind of crooked, and it says something here that's very difficult to read. And what I figured out that it says after tracing the circuit around the board is it says from switch. Now there's a maintenance switch on the board. And okay, what does the maintenance switch do? Because that is what led me to what I believe is wrong. And I haven't actually tried this yet, so we're going to see together. What the maintenance switch does is it allows you to ground the vertical hold and vertical height controls instead of tying them to 12 volts. And what that does is that drags the chip down to a collapsed line. What do we have? A collapsed line. Why does it draw it down to a collapsed line? It does it so that you can adjust the white balance. So when the monitor is not being fed a signal, you might have a little bit of raster if you turn the brightness way up, but you're not going to have anything on the screen. So in order to get color on the screen, it collapses the signal to nothing. Well, I switched the switch back and forth, and nothing changed, including the output of the switch, which is an extremely low voltage. So what I think happened is, over time, the switch is corroded internally and it's not making contact anymore. Now I can show you what it's doing here. If we plug this monitor in, everything is still on. I hear screen warm up here. And if I take my probe here, and I'm going to give you to the oscilloscope. Nope, I want to go the other way. You'll see if I measure the input to the switch, see we have 12 volts. All right, I'm looking at the input to the switch. If I measure the output of the switch, which is going up here to the control for vertical hold and over here to the control for vertical height, here, so this is the output of the switch. The other side, incidentally, is ground, right? So when you switch it to maintenance position, you ground it. What do we have? Of course, now we have 12 volts. A minute ago, we had nothing. Did the switch just fix itself? It may have fixed itself. I gotta look at the screen to see. We're not collapsed. I'll be darned. And I was not wrong, but my flipping it back and forth and turning the monitor on and off enough times, look, we don't have a collapsed line anymore. I ordered a chip, I installed the chip, I took the monitor all apart and put it all back together, and all I had to do was probably flip that switch back and forth 3 or 4 times, and the monitor would have been fixed. Well, but today we learned something. We learned that when we're working on these older pieces of equipment, that maybe we shouldn't always consider that the manual is going to be 100% right. Because when they wrote that manual, they said to themselves, The only thing that can cause this line to be collapsed is this chip went bad, because, and it would if that chip went bad, because that chip drives the amplifier that drives the yoke to make the vertical deflection so that we can have a full signal. Yeah, so they never expected that the switch would be corroded, because they never thought to themselves, you know, they never expected that somebody 43 years down the road was going to still be using this monitor. So, and since I didn't read the book the first time, but I went right to the end and tried to see how it came out, I got punished by having to buy a chip, wait a week, and learn that there was nothing wrong with the chip to begin with. So I'm going to leave all this in the video. I think this is good, because this is the kind of thing, you know, that over time helps us learn how to repair electronics. So what I'm going to do is I am going to bridge. I think I'm just going to remove the switch, because we know the switch is bad. I'm likely never going to adjust the white balance in this monitor, so I don't really need the maintenance switch. And then I'm going to bridge the sides of the switch that puts it in the normal position with a piece of wire and call it fixed. I don't want to try and find a switch that fits in there, hope that that switch doesn't go bad. I just want this monitor to work so we can move on to our next project, which is pimping out a nice 5150 that I bought with some neat aftermarket cards and seeing what we can make it do. So let me go ahead and get that repair done. We'll put this monitor back together. Okay, so all I did here is shorted, you know, the center to the bottom position here and here, which would be the positions that the switch would be in when it was not in maintenance mode. So it should just be permanently switched in not maintenance mode. Up here, this big, you know, trace here that goes all over the place, this is just ground. And so yeah, switching it up it disconnects this side, because this had no connection here, but then it grounds this side, and this is the side that goes to, yeah, that's the side there that goes down to the IC, what is it, 301, the AN5410, the one we replaced. I'll leave that new one in there. I'm not going back in there to take that chip back out. There should be no difference between the new one and the old one, and seems like it's working. So before I clean all this up, I'll get it plugged in just one more time and make sure we've still got a full screen and not collapsed video. And if we do, I'm going to go ahead and tidy up the inside of this with some zip ties, and we'll get the case back together and go ahead and plug it into the 5150 and see if we get a picture. Stay tuned. All right, here goes. Are you ready? Get set. I hear the high voltage. No whammies. Haha! Look at that. We got a full screen of raster. This is beautiful. I was getting a little worried there. I didn't think we were going to be able to figure out what was wrong with this thing. So I'm going to turn it back off. I'm going to clean up the inside and get the cover back on. And this is very exciting. We're going to see some text on the screen, hopefully here in a moment. Okay, there we are. It's all back together. Actually, it went together pretty good. And I know what you're thinking. You're probably going, Joe, why didn't you adjust that monitor? Well, you had it all apart and get it all dialed in. And well, we are going to do that in the future. The problem is I don't have a way right now to display color bars or patterns or anything on this screen. So until I get the 5150 up and running where I can actually use it, we're not going to be able to display much but a little bit of text on here, and that's not really enough to make a proper adjustment. So this May have to come back apart if screen geometry and things like that or colors are all messed up. Maybe not. Maybe it just looks fine in the future. So right now, I'm going to get everything set up to test this with the computer, and I'll be right back. Stay tuned. Okay, I'm back. I got everything cleaned up and set up, and we're going to watch this together. I've not tried this before right now, I promise. So let's flip this around. This is the setup here, looking very IBM-y. And let's start with monitor. A pilot lamp, that's a good sign. This thing takes a second to warm up, so we got to give it a chance here before we fire the computer up. Make sure. Well, I don't know. Let's just give it some computer. It was the 80s. Everything is a bit slow. Oh, there's something. Probably got the horizontal hold and everything all out of whack because I was playing with those knobs. So let's, aha! What do we see? All right, look at that. I got some basic up and running on the screen. Yeah. A little dimmer than I expected it to be, but it's probably got to warm up a little. And yeah, there we go. We can probably let's grab an adjuster here, and I think we can pull the vertical size down a little bit. Sorry, bear with me as I try and go around the back here. Oh yeah, there we go. And again, I might have to play around with the positioning and things, but yeah, that looks really good. And I'm happy. Yeah, this is a win. You know, for a moment there, I was getting a little worried that we weren't going to figure out what was wrong with this monitor because it just wasn't doing what the manual said it should do. And the troubleshooting guide in the manual did not help because it sent me down a rabbit hole I shouldn't have went down. So today, I learned a little bit. Hopefully I helped you learn something too. So thanks for tuning in to the channel here and watching my video. I hope it was entertaining and educational at all, if it could be at all. And if you like my videos and you want to support me, I really would appreciate a like. If you don't like my videos, well, that's fine too. You can hit a dislike. We're open to any kind of criticism here at N9TAX Retro Lab. And yeah, and if you'd like to see more of my videos in the future, smash that subscribe button. It does help the channel out, gets the videos out there, and helps with the algorithm. So until the next one, this is N9TAX Retro Lab, signing out.